Okay, so today I want to talk about section 6.8, indeterminate forms, L'Hopital's rule, and relative rates of growth. It's like outline. I want to talk about the 4 kinds of limit problems today. The first problem is limit of f of x over g of x as x value approaches a. Second problem, limit of f of x times g of x as x approaches a. Third problem, limit of f of x minus g of x as x value approaches a. The last one, limit of f of x to the g of x as x approaches a. So I'm going to talk about what are indeterminate form. So case 1, indeterminate quotient. So from this one, what's that? I will explain later. Second one, indeterminate product here. So what's that? What is indeterminate product from the second problem? The third one, what is the indeterminate difference from third one? The last one, what is the indeterminate power? So from here, what is indeterminate power? So I can talk about these kind of things. How can you find the limit of indeterminate form? We have algebraic method, the L'Hopital's rule, and relative ratio growth. Today we focus on second method and third method, exactly today's lecture. What's the indeterminate quotient? Consider type 0 of 0, infinity of infinity form. The type 0 of 0, like this. The limit of x as x value approaches 0, you plug 0 into bottom and top on exactly 0 of 0 form. How can you calculate? Only cross out x 1 of 1. The limit of 1 is 1. What does it mean? Limit exists. Type 0 of 0, like this one, x of x squared. You plug 0 into top on and bottom on the exactly 0 of 0 form. How can you calculate? Cross out one common factor x, 1 of x. X value approach 0 from the right. So what happens? You can sketch the graph 1 of x. It's like 1 of x. X value approaches 0 from the right. The 1 of x is going up, going to the positive infinity. What's the answer? Answer is infinity. What's like infinity? The limit does not exist. What's like infinity of infinity form? The similar one. Limit x of x as x value approaches infinity. You can plug infinity into top and the bottom one. We have infinity of infinity form. How can you calculate? Only cross out common factor x, limit of 1. The limit of 1 is 1. Because the infinity is not a finite. This is the reason. The limit does not exist. So what does it mean, the existence of a limit? The limit is only finite. The limit is only finite. We call the limit exists. The limit is not a finite. The limit does not exist. Does it make sense? Okay, here. The limit is like 1. The limit exists. The limit, the type infinity of infinity. The limit of x squared over x as x value approaches infinity. The same. You can cross out x, only x. Plug here infinity, the same. The infinity is not a finite number. Limit does not exist. So what does it mean? The limit may or may not exist in type of 0 over 0 or infinity, right? Here, sometimes it exists, sometimes it does not exist. So infinity over infinity form, sometimes it exists, sometimes it does not exist. So it's called an indeterminate form of type 0, 0, infinity over infinity. We call indeterminate form. How to find the limit of indeterminate quotient? So like this. You plug 1 into top one and bottom one. So what happens? The 1 square minus 1 over the 2 times 1 square minus minus 1 and minus 1. This is like a 0 over 0. The exactly indeterminate form, just polynomial over polynomial. How can you do that? You have to factor. So top one is x minus 1 times x plus 1. Bottom one, x minus 1 times 2x plus 1. So you have to cross out x minus 1. We have it. Next, you can plug 1 into top and the bottom one. So we have 1 plus 1 over 2 times 1 plus 1. Answer is 2/3. So that's it. This is the answer by using algebraic method. Here, x value approaches infinity, so what happens? You plug infinity into top one and bottom one. What happens? The infinity square minus 1 is infinity. The infinity square minus infinity minus 1 is like infinity. So we have infinity over infinity form. How can you solve? Only divide top one and bottom one by highest power term in the denominator x squared. Right? Divided by x squared. Like this. Next, distribute 1 over x squared to the first one. X squared is crossed out, just 1. The minus 1 times 1 over x squared is negative 1 over x squared. You can distribute 1 over x squared to the first, second, and third one. We have 2 minus 1 over x minus 1 over x squared. So what happens? X value approaches infinity. The 1 over infinity square is going to 0. 1 over x is going to 0. 1 over x squared is going to 0. What are the remaining things? 1 over 2. So that's it. This is the whole idea for solving this problem. Like this. It is possible to find the above limits by algebraic method. What's that? You can plug 1 into top one and bottom one, the ln of 1 over 1 minus 1. Exactly 0 over 0. So what's that? I cannot use algebraic method. We don't have any common factor. You cannot divide, you cannot cross out common factor. Impossible, because ln of x is not a polynomial. X value approaching infinity, you plug infinity into here. Top one is infinity. Plug into bottom one. The infinity minus 1 is also infinity. Infinity over infinity. So similar. So we cannot solve by using algebraic method. Really complicated. So how can you find limit of indeterminate form of 0, 0 or infinity over infinity? So main tool is today's title, L'Hopital's rule. So what is like L'Hopital's rule? I'm going to explain L'Hopital's rule here. Suppose the function f and function g are differentiable and g prime of x is not equal to 0 on an interval I that contains point A, except possibly at A. Suppose that the limit of f of x is going to 0, limit of gx equal to 0, or limit of f of x is going to plus or minus infinity, limit of g of x is going to plus or minus infinity. So in this case, we have type 0 over 0, infinity over infinity. Two types. How can you solve? Limit of f of x over g of x is exactly same to limit of f prime of x over g prime of x that we call L'Hopital's rule. L'Hopital's rule. So here, if the limit on the right side exists or is infinity or negative infinity, note x approaches a can be replaced by any of the symbols. X value approaches a from the right, a from the left. Infinity minus infinity. But it doesn't matter. You can use one-sided limit or infinity minus infinity. It's good for using L'Hopital's rule. What's like a key? This one. Limit of f of x over g of x is limit of f prime of x over g prime of x. So when do you use L'Hopital's rule? Only 0 over 0 type or infinity over infinity type. We have two types. So this is like L'Hopital's rule. We are going back to previous example. What's like the first one? You can plug 1 into top one and bottom one. ln of 1 is 0. 1 minus 1 is 0. Exactly. The 0 of 0 form, you have to use L'Hopital's rule. What is ln of x prime? Could you write new answer? What's ln of x prime? What's that? Could you write new answer on the chatting board, please? Okay. The ln of x prime is, what's that? Okay. Okay, good. The x minus 1 prime is just 1. So we have limit x value approaches 1, just 1 of x. The last one, plug 1 into x, 1 over 1 is 1. But that's it. This is the answer of the first question. Like this. The second one, x value approaches infinity, ln of x over x minus 1. So similar. You plug infinity into x, ln of infinity is infinity. Infinity minus 1 is infinity. Exactly this type. I want to use L'Hopital's rule. Like this. The same. ln of x prime is 1 over x. X minus 1 prime is 1. Exactly like this. X value approaches positive infinity. What happens? 1 over infinity is just 0. So that's it. This is the whole idea for solving this kind of problems. So one more. What's that? So similar. You can plug 0 into here. Exactly tangent of 0 minus 0 over 0 cube. The tangent of 0 is 0. 0 cube 0 like 0, 0 over 0 form. We have this type. You can use L'Hopital's rule. What is tangent prime? What is tangent prime? Could you write the answer on your chatting board, please? What is it like tangent prime of x? Okay, okay, good. Secant square of x minus x prime is 1, x cube prime is minus 1. You plug 0 into x again. We have secant square of 0, secant square of 0 minus 1 over 3 times 0 square. What is secant of 0? So could you write your answer on the chatting board? What is secant 0? Could you write your answer on the chatting board? Okay, okay. Yeah, secant of 0 is exactly 1 over cosine of 0. You can use identity. Cosine of 0 is 1, answer is 1. You can plug 1 into here. We have 1 square minus 1 over 0 is 0 over 0. We have this type. What does it mean? You can use L'Hopital's rule again. What is secant square of x prime? Here we have secant square of x prime is, you can use a chain rule, twist down secant square of x times inner function secant x prime. So we have 2 times secant x. Secant x prime is secant x times tan x. Exactly 2 times secant square of x tangent of x that we have it, right? So we have this result, like this. The combine and split. The one more. You plug 0 into x. So what happens? Secant x is 1. Secant x is 1. You can split non-zero part. You plug 0 into here. Tangent of 0 is 0. X, plug 0 into x. This is also 0. You can just split non-zero part and 0 part. The next, distribute limit. What's that? This is limit. X value approaches 0 to secant square of x over 6 times limit. X value approaches 0, tangent of x over x. you plug 0 into here, what is the answer? Answer is 2 times secant square of 0 over 6. Limit x value approaches 0, the tangent x over x. Right? So we have like this. So one more. The secant of 0 is just 1. The plug 0 into top and the bottom on tangent of 0 is 0. Bottom is like 0. 0 of 0 form. You can use L'Hopital's rule. So we have the simplify 2 is crossed out, only 1/3. We have it. You can use L'Hopital's rule. The tangent prime is secant square. The x prime is 1. 1/3 limit secant square of x of 1. You can plug 0 into x, the 1/3 secant square of 0. Secant square of 0 is just 1. The 1/3 times 1 is 1/3. So that's it. This is the whole idea for solving this problem. So next tip. The limit sin x of 1 minus cosine x is given. You can use L'Hopital's rule. The sin x prime is cosine. The negative cosine x prime is positive sine. So we have it. So let me see. You plug pi into top one and bottom one, what happens? I want to use graph. Cosine graph is like this. This is like pi. And going up like this, cosine of x. So what's that? Cosine pi over sine of pi. Cosine pi is -1. What is sine pi? The sine graph is like this. This is pi, the sine of x. Sine pi is 0, the negative 1 over 0. So what does it mean? So we have two possible answers. Non-zero of 0 form, we have two possible answers from the one-sided limit, positive infinity, one negative infinity. How can you decide? You can use one-sided limit. X value approaches pi from the left, cosine function is below x-axis, negative. So cosine function is negative. X value approaches pi from the left, so sine function is above x-axis, positive. It's positive. What is the answer? Answer is negative infinity. So what do you think? This answer is right or wrong? This is right? What's that? What is your, it's good? This is right? So you cannot find my mistake? So this is right? This answer? What do you think? This answer is like true or false? This answer is true or false? What do you think? What do you answer? So what does it mean the numerator wrong? What does it mean? Numerator wrong? I don't think so. But this is right. The cosine x is right, I think. Sine prime is cosine x, no problem, I think. So what kind of wrong? So this answer is like, this is wrong. So which step is wrong? Step 1, step 2, step 3. So which step is wrong? Could you decide? So which step is wrong? Step 1, step 2, step 3. Which one? So which step is wrong? Second step? No, it's right. The second step is right. The remaining part is step 1, step 3. Step 1 is wrong? Yes, step 1 is wrong. Here. So when do you use L'Hopital's rule? Just what? The 0 of 0 or infinity of infinity. We can use L'Hopital's rule, just like idea here. This one. So you can plug x equals pi from the left into sine x and the cosine x. You can plug pi into here. What's that? Only 0. You plug cosine x, -1. We have, yes, 0 over 2. What does it mean? Don't use L'Hopital rule. Don't use L'Hopital rule. Don't use L'Hopital rule. When do you use L'Hopital rule? Only 0 over 0, infinity over infinity. You can use L'Hopital rule. The 0 over non-zero number, don't use. Don't use. This is wrong. So not indeterminate form, don't use L'Hopital rule. What is the answer? Only plug a number. So 0 over 1 minus 1 is 0 over 2 is like 0. That's it. This is answer. Don't use L'Hopital rule. Really be careful. So when do you use L'Hopital rule? 0 over 0, infinity over infinity. Only this case. The next question. The limit of f of x over g of x, infinity over infinity form. How can you find limit of f of x over g of x as x value approaches infinity? Really be careful. What kind of case? X value approaches only positive infinity. We have infinity over infinity form. 0 over 0 form, don't use the following method. Only infinity over infinity form. X value approaches infinity. You can use this following forms. Use relative rate of growth. So what's that? Or L'Hopital rule. The definition of grows faster than g of x. The function f of x, the grows faster than g of x. So what's that? As x value approaches infinity, the limit of f of x over g of x as x value approaches infinity is infinity. What does it mean? The top one is growing faster than bottom one. So in other words, the interchange top and the bottom one. The limit of g of x over f of x is going to 0. What does it mean? The bottom one is growing faster than top one. So one more. We also say that the g of x grows slower than f of x. That's right. It's another way. Was it like notation? We can use this notation. What does it mean? Here. The f of x is growing faster than g of x. That's the notation. One more. F of x and g of x grow at the same rate as x value approaches infinity. So what's that? This is the definition. The limit of f of x over g of x as x value approaches infinity is like finite number m. M is a finite, the non-zero finite number. So we'll denote this by this one. We have same rate. This bridge is what? Same rate. Bridge is the same rate, so like this. You can use it. So let me see. So we can make some table. The limit ln of x over ln of ln of x. You can plug infinity into top one and bottom one. So exactly infinity over infinity. You can use L'Hopital rule. What's like ln of x prime? The ln of x prime is here. ln of x prime is 1 over x. Do you know what is ln of x prime? So could you write your answer on the chatting board? What is ln of x prime? What's that? Do you know answer? What is ln of x prime? Okay. How about other guys? Okay. Okay, good. So we can use chain rule. It's like inner function prime over inner function. ln x prime is 1 over x over ln of x. You have to simplify. Numerator is 1 over x times reciprocal of denominator 1 over x times ln of x. So you have this one. You can plug. Sorry, this is 1 over x, not x. ln of x prime is 1 over x. You plug into here and here. So we have it like this. To simplify, right? The numerator 1 over x times reciprocal of denominator. The next, the cross out x only ln of x. The x value approaches infinity, plug infinity into here. ln of infinity is infinity. So which one is growing faster? Only top one is growing faster. So like this. Was it like ln of x over x? So same. This is plug infinity into top one and bottom one, exactly infinity over infinity. You have to use L'Hopital's rule. The ln of x prime is 1 over x prime is 1. So simplify. So x value approaching infinity, plug into here. 1 over infinity is just 0. So which one is growing faster? In this case, bottom one is growing faster. The next x squared and the e to the x, the same. The x value approaching infinity, the infinity over infinity, you can use L'Hopital's rule. The x squared prime is 2x. The e to the x prime is e to the x. So also plug infinity into top one and bottom one. 2 times infinity is infinity. E to the infinity is infinity. Exactly L'Hopital's rule. The 2x prime is 2, e to the x prime, e to the x prime is e to the x. X value approaching infinity, what happens? 2 over infinity. Answer is 0. Which one is growing faster? The bottom one is growing faster. We can combine this whole result. We have one good chain. What kind of a chain? Like this. The ln of x is growing faster than ln of x. So this is growing fast. X is growing faster here. So this is very clear. X squared is like growing faster, and e to the x, so like this, and keep going. We can make this kind of chain. You need some of the test like this. You have the one good chain. What kind of chain? So like this. X to the x is really fast. The growing faster than b to the x. The b to the x is growing faster than a to the x. Exponential function is growing faster than any algebraic function, x to q. X to q is growing faster than x to p. This relation, p is less than q. So one more, you can compare any kind of things and the ln of x. The ln function is really, really slow. The 2ln function really slow. So I want to give one example. Limit x value approaches positive infinity. What is the square root of x over ln of x to the 100? What is answer? Could you write your answer on the chatting board? So what is answer of this question? So by using this chain, what is your answer? So which one is growing faster? Top one is growing faster, answer is infinity. The bottom one is growing faster, answer is 0. We have two possible answers, infinity or 0 in this problem. So what's that? Top is growing faster? Yes. Here, what's that? The limit x value approaching infinity, I can change it to the power form, ln of x to the 100. You can compare. X to the what? P is 1/2. Beta is 100. So x to the 1/2 is growing faster than ln of x to 100. So what is the answer? Top one is growing faster. Answer is infinity. It's good. So one more. Limit x value approaching infinity. So 2 to the x over 5 to the x. What is your answer? What is your answer? Answer is like 0. Is it right? How about other students? The same answer? What is the answer? The which one is growing faster? You can use this rule. The 2 is base, 5 is base, like exponential function here. The 2 is base here. The 2 is base. The 5 is base. Is it right? You can use 2 and 5. So like this. 5 to the x is growing faster than 2 to the x. The bottom one is growing faster than top one. Yes. Answer is 0. That's it. This is the whole idea by using relative ratio growth. So you have to memorize this chain. Really, really useful. This one, only just x value approach to infinity. We have infinity form. You can use this chain. Was it like alpha? Just positive. Beta is positive. P is positive, Q is greater than P, you can use exponential function. A is greater than 1, the P is greater than A. So here, you can think about it. What's that? ln of x 100 is this top one. We have ln of x to the 100 is this position. ln of x is here. ln of x to the power 1. The tangent constant. Which one is growing faster? ln of x is growing faster. You have to ignore slow one and constant. The root x and the 1 cross out. Just two, we have ln of x and the root x. So we have limit x value approaches infinity, ln of x, square root of x. So what's that? Limit x value approaches infinity, the ln of x, the root x is x to 1/2. You can have it. This is what? X to the 1/2. X to 1/2 is growing faster than ln function. So what happens? This one is growing faster than ln function. Bottom one is growing faster than top one is 0. So we have it like this. It's good? Chain. Second one. What is your answer? So could you run your answer on the chatting board? For second example, what is your answer? The limit 9 to the x plus 4 to the 2x plus 10 over 10 to the x plus x to the 1000 plus ln of x to 20 plus 1. What is your answer of this equation? Answer is 0. 0 is right. 0. 0. No, not 0. Answer is infinity, unfortunately. The y, the really be careful. So if you didn't use this chain, what's the power? Power is just x. So this is 2x. You can change it. 4 to the 2x is the 4 squared to the x, exactly change it to the 16 to the x. You can change it like this. Next, compare. 9 to the x is here. 9 to the x, here 16 to the x. The 16 to the x is growing faster, ignore 9 to the x and constant. The next 10 to the x. Here we have 10 to the x is bottom on, x to 100, 1000 is here. So ln of x is here to the 20. So which one is growing faster? The 10 to the x is growing faster, ignore remaining terms, slow one. So we have only 16 to the x, 10 to the x. So we have it. You can compare the 16 to the x, 10 to the x. The 16 to the x is growing faster than 10 to the x. So answer is infinity. That's right. This is like idea. The next one. This case is really be careful. So only compare x to 5 and the 1. Was it constant? You have to ignore 1. So we have only limit x value approaches infinity, the ln of x to the 5 over ln of x. We have the one good rule. 5 is like down. You're right. The bottom one is growing faster than top one. Answer is always 0. Top one is growing faster than bottom one. Answer is always infinity. You're right, yes. So 5 is down. The limit x value approaches positive infinity. 5 times ln of x over ln of x. ln of x is crossed out. Answer is just 5. So we have it. This answer, right? Like this. Okay, this is exactly the relative ratio growth problem. The next one. My infinity though works, is right. So we have a different sign. Top one is going to negative infinity. Bottom one is going to positive infinity. We have a different sign. So top one is growing faster than bottom one. Answer is negative infinity. You're right. This is possible. So we have a different sign. The different sign, negative infinity. But top one is a negative sign, bottom is like a positive sign. You can only check the bottom one is growing faster than top one. We don't take any sign. The answer is always zero, right? Only top one is growing faster. Two possible answers depending on sign of top one, sign of bottom one. Okay, this is the answer of your equation. So next is the indeterminate product. So what's that? Here, limit of f of x times g of x as x value approaches a. So what's that? The one example, x value approaches infinity, the 1 of x is going to 0. X is going to infinity, right? So what happens? Just cross out x, answer is 1, limit exists. Type 0 times infinity. Second one, same. 1 of x is going to 0, x squared is going to infinity. We have a 0 times infinity form. What is answer? Only cross out x, limit of x. The limit of x as x value approaches infinity, answer is infinity. The limit value is not finite. Limit does not exist. What does it mean? The limit may or may not exist in type 0 times infinity. So we have a name that we call indeterminate form of type 0 times infinity. 0 times infinity. So how to find limit of f of x times g of x on indeterminate form of type 0 times infinity? We have two possible things here. You can change it like this. F of x is going to numerator, g of x is going to denominator by using reciprocal. What does it mean? It's like 0 times infinity form. The top one is going to 0, 1 over infinity is going to 0. We have 0 over 0 form. How can you solve a 0 over 0 form? You can use L'Hopital's rule. This is the idea. Another way is here. The g of x is going to top. F of x is going to bottom by using reciprocal. We have 0 times infinity form. G of x is infinity. 1 over f of x is 1 over 0 form. The 1 over 0 form is only two possible answers, positive infinity, one negative infinity. What does it mean? Infinity over infinity. You have to use L'Hopital's rule. It's like a whole idea. So we have two possible types. What's that? The g of x is going to denominator, or f of x is going to denominator. You have to decide very carefully. So which one is going to denominator, which one is going to top one. Here, what's that? We have two possible things. The first one, this is like an indeterminate form. X value approaches 0, x value approaches 0. What's it like ln of x? You can draw the graph of ln of x. So this is ln of x. X value approaches 0 from the right. ln function is going down, negative infinity. Exactly 0 times infinity form. We have indeterminate form. We have two possibilities. First one here, x is going to top, ln of x is going to bottom. This is like type 1. Second possibility is here, the ln of x is going to top, the x is going to the bottom. So which one is like better? So only trial and error. So we have like this. You can try first possibility. You can use L'Hopital's rule. So x prime is 1, is right here. X prime is exactly 1. What is the 1 over ln of x prime? 1 over ln of x prime is, use quotient rule, the 1 prime times ln of x minus 1 times ln of x prime over bottom one ln of x squared. 1 prime is 0. ln of x prime is 1 of x, keep negative sign, minus 1 of x, ln of x squared. Same to negative 1 of x times the reciprocal of denominator, 1 over ln of x squared. So we have negative 1 over x times ln of x squared. You can plug this one into here. We have the minus 1 over x times ln of x squared, right? So we have it. We can have this kind of things. So we have this result. The next is, when you think about reciprocal, so like this, what happens? The original problem has only x times ln x. The resulting equation has x times ln of x squared. What does it mean? More complicated. What does it mean? It's not a good choice. It's not a good choice. You can use second one is better. Try second one. Same. You can use L'Hopital's rule. The ln of x prime is 1 over x, right? ln of x prime is 1 over x. 1 over x prime is negative 1 over x squared by using quotient rule, like this. So we have limit. X value approaches 0 from the right. You have to keep 1 over x times the reciprocal of denominator, x squared of minus 1. X is crossed out. We have limit. X value approaches 0 from the right. The minus 1 times x is negative x. You can plug 0 into x. Answer is 0. That's it. This is the whole idea for solving this problem. So which one is better? This is better. So we have one good idea. This is a product of polynomial and ln function. What's the best way? Don't choose first case. ln function is always going to what? Numerator. The polynomial is going to fraction. It's like a good choice, right? The good choice. The next one, indeterminate difference forms. The f of x minus g of x form. So what's that? So we think about x minus x. You can plug infinity into x. So we have infinity minus infinity form, right? But answer is 0. The limit exists. X squared minus x, same. This is infinity. The infinity into here, infinity. Infinity to here, infinity. Exactly, infinity minus infinity. How can solve? Factor out x. X value approaches infinity. X minus 1 approaches infinity. Infinity times infinity is infinity. The limit value is not finite. Limit does not exist. This limit may or may not exist in type infinity minus infinity. So we call indeterminate form of type infinity minus infinity. How to find the limit of f of x minus g of x as x value approaches a indeterminate form of type infinity minus infinity. The idea is next one. Try to convert the difference into a quotient. For instance, by using a common denominator or rationalization or factoring out a common factor. That was like main idea, convert difference into quotient form, like a fraction form. This is like idea. So that we have an indeterminate form of type 0 of 0 or infinity of infinity. So like this. So let me see. What's the best one? You can use this one. What's the secant of x? Secant of x is 1 over cosine. The secant of x. X value approaches pi over 2. Plug pi over 2 is bottom on 1 over cosine of pi over 2. 1 over cosine pi over 2 is 1 over 0 form. It's like a one-sided limit. We have two possible answers, infinity or negative infinity. Just definition. What's it like here? One example, limit x value approaches a from f of x equal to L. It's like exists. So what does it mean? L is what? Finite. Only definition. Only definition. L is infinity. Limit value does not exist. Does not exist. Only definition. Yeah. The infinity is not a finite number. What's like infinity? I don't know. What's infinity? It's not finite. So not in real world. The infinity is not in real world. So this is like does not exist. Only definition. Only definition. Yeah, it doesn't matter. The limit of x value approach infinity. In this case, only think on the limit value. The f of x is like infinity. Limit does not exist. Limit f of x as x approach infinity is 5. Yes, limit exists. But depending on limit value. The limit value is infinity or not. Infinity does not exist. The finite exists. It doesn't matter. X value approach infinity, X value approach finite number, we don't care. The approaching number, only result. Only result. It's good. So this is like exact idea of limit values. So anyway, here, the 1 over 0 form. So in this case, it's like indeterminate form. What's like indeterminate form? So we have like 0 over 0 form is indeterminate form. Why? Depending on problem. Limit x value approaches like the infinity. X over x square. Exactly 0 over 0 form. Sorry, we think about infinity form. Infinity form. So what is the answer? Limit x value approaches infinity 1 over x. Answer is 0. Limit exists. Right? Only indeterminate form. So limit x value approaches infinity, x square of x is similar idea. X value approaches infinity, x is like infinity, limit does not exist. We have same form. The infinity, same form, limit does not exist. No, depending on problem, the similar. You can use L'Hopital's rule. So answer is finite. So answer is infinity, depending on problem. So we don't know. Was it like indeterminate form? Sometimes finite, sometimes infinity, depending on problem. So one example is next one. The 0 of infinity form. Was it 0 of infinity form? You can use any kind of things. The always answer is what? 0. The always 0. What does it? Determinate. Determinate. It's like not indeterminate form. That makes sense? So how can you know some of the indeterminate form? So we have the same kind of form, infinity over infinity. You can use any kind of like examples. Some examples have finite number. Some examples have infinite numbers. We call indeterminate form. You can choose any example of 0 over infinity form. You can try to solve this problem. What's that? We have only one possible answer. It's always 0. So we call determinate. Right? It's like idea of this kind of things. It's good. So if we have more question, you can write your question on the chatting board. I'll explain. I'll do my best to explain. Okay, good. Yeah, good. Okay. Any trouble in your question? Don't worry. Always write your question on the chatting board. I'll answer your question. Okay. So we are going back to this problem again. The secant of x is 1 over cosine of x. X value approaches pi over 2, plug pi over 2 into x, 1 over cosine pi over 2, 1 over 0 form. You can draw graph of cosine. Graph of cosine is like this. This is cosine of x. This one is like pi over 2. X value approaches pi over 2 from the right. So this is just above x. X is positive. Top on positive, bottom positive. So what does it mean? Secant x is going to positive infinity. What's the tangent of x? You can draw graph of tangent. The graph of tangent is like this. X value approaches pi over 2. What's the tangent function? Tangent function is going to positive infinity. Tangent function is going to positive infinity. We can take a negative. We have infinity minus infinity. So we have indeterminate form. So how can solve this problem? This is the key. You can change the difference into quotient form. It's like idea. So what's that? Here, change it to the quotient form. What's it like identity of secant? The identity of secant is 1 over cosine. The identity of tangent is sine over cosine. You can change it to these kind of forms. You can combine limit 1 minus sine x over cosine x. You plug the pi over 2 into top one and bottom one. So what happens? 1 minus sine of pi over 2 over cosine pi over 2. What's that? 1 minus sine pi over 2 is 1. Cosine pi over 2 is 0. We have 0 over 0 form. You can use L'Hopital. The 1 prime is 0. Sine prime is cosine. Cosine prime is negative sine. You can keep negative. The negative cosine of negative sine. The eliminate. This is like negative sine. Only plug pi over 2 into x. We have cosine pi over 2 over sine pi over 2. Cosine pi over 2 is 0. Sine pi over 2 is 1. The 0 over 1 is only 0. So that's it. This is the whole idea for solving this problem. So next thing, indeterminate power forms. So what's that? The limit f of x to the power g of x, this kind of forms. So you can take ln. Take ln, f of x is g of x. The top g of x is down. We have product one. Was it like indeterminate product form? Only one type, 0 times infinity, right? We have the infinity times 0 form. Here, g of x is infinity. ln over f of x is like 0. Here, ln over f of x is like 0. What is f of x? So my question is, ln of f of x is like 0. What is f of x? Do you know? Could you run your answer? So ln of f of x equal to 0. What is this one? So what's that? So what's that? Here, do you know this one? What's the ln function? The ln function is like this. So this is 1. What does it mean? ln of 1 equal to 0. So here, the ln of f of x is like 0. What's f of x? F of x is just 1. G of x is going to infinity. So we have 1 infinity. F of x is 1. G of x is infinity. We have this kind of things. Another case is, was it like this form? 0 times infinity. 0 times minus infinity is also indeterminate product. So g of x is going to 0. It's good. G of x is going to 0. The ln of f of x is going to minus infinity. So what happens inside 1? What's inside 1? What do you think? What's inside 1? This is similar. Here, the ln function is like this. This is ln of f of x. This is like x is like f of x. ln function is going down. What happens? X-axis. X-axis approaches to 0, right? F of x approaches 0. We have minus infinity. We have 0, 0. It's like a second one. The last case is 0 times infinity. So g of x is going to 0. G of x is going to 0. What's like ln of f of x going to positive infinity. So we have this one. Same. Use ln of f of x. The ln of f of x is going to positive infinity. Was like f of x. F of x is log of x-axis. The log of x-axis is going to positive infinity. So we have infinity. Right? So we have it. You can change it to this form. So from here, you can change it to the f of x to the power g of x form. Change it. What's that? We have indeterminate form is like this one. 1 to infinity. Is right? 1 to infinity. Here, 0 to 0 form. Third one, infinity to the 0 form. We have 3 possible indeterminate form from the powers. From the powers. It's like idea. Like this. 1 to infinity, 0 to 0, infinity to 0 form. We have this one. The next, how can you find limit of f of x to the power g of x as x value approaches a? We can follow these steps. Step 1, take the natural logarithm on f of x to the power g of x. What does it mean? Like this one. Take ln of f of x to the power g of x. Power g of x is like down. Down. We have g of x times ln of f of x. Next, step 2. Take the limit as x value approaches a. You can take the limit, right? Here. This form is given. Only take limit both sides. So how can you do that? This case is exactly 0 times infinity or infinity times 0 form. Exactly the indeterminate product form. How can you solve? You can change the fraction. As I said before, ln function is going to top is better. The g of x is going to bottom on. You have to use L'Hopital's rule and find answer. Find answer. So this is answer of limit of ln f of x g of x is L. So my question is, what's the original problem? The original problem is limit of f of x to the g of x. We don't have ln. How can you eliminate this ln? Do you have any idea? How can you eliminate this ln? So could you write a new answer? How can you eliminate this ln? From here, how can you eliminate ln? Do you have any idea? So could you write a new answer on the chatting board? So my point is the limit of ln of f of x to g of x equal to L. How can you eliminate ln? Do you have any idea? The idea is take E here. Natural exponent to E. Yeah, this is like the idea. So only take what? E to the both sides. Take E like this. What happens? Here, the E is going to inside of a limit. This is possible like this. E ln is cancelled. So we have limit of f of x to g of x equal to E to the L. This is the final answer. That's right. This is the final answer. E to the L. This is the whole idea. Always follow 3 steps. 3 steps. So let me see this problem. X value approaching infinity, what happens? The x value approaching infinity, the 3 of x is going to 0. Exactly 1. X is going to infinity. So we have infinity. 1 to infinity form. So going back, yes, 1 to infinity form. I can follow 3 steps. The 3 steps. Step 1, take ln. 1 plus 3 of x to the x take ln. The power x is down, right? So power x is like down. So x times ln of 1 plus 3x. Step 2, take limit. So take limit of this expanded form. Take limit. The x is going to denominator. ln function is going to numerator. X is going to denominator. So you can use L'Hopital's rule, right? You can change it. This is like better. So before you take L'Hopital's rule, you can change this one. 1 plus 3 of x is exactly, what's that? So this one is 1 plus the 3 of x is x over x plus 3 over x. You can change to only one fraction, x plus 3 over x. The next, expand. ln of x plus 3 minus ln of x. Next, you can use L'Hopital's rule. The L'Hopital's rule. What's that? So this is same to limit. X value approaches positive infinity. ln of x plus 3 prime is x plus 3 prime over x plus 3 minus ln of x prime is 1 over x over the 1 over x prime is, you can use quotient rule. We have a negative 1 over x squared. So we have limit. X value approaches positive infinity. X plus 3 prime is only 1. 1 over x plus 3 minus 1 over x over minus 1 over x squared. The next, you have to simplify by using common denominator. X plus 3 and x, you can multiply top one and bottom by x. Here we need x plus 3. Top one is only x minus x plus 3 over x times x plus 3 over negative 1 over x squared. So simplify. Distribute negative 1. X is cancelled. Negative 3 is top over. Distribute x to the x and the 3. We have x squared plus 3x times the reciprocal of denominator, x squared over minus 1. So what's that? You can change it positive like this. Limit x value approaches infinity. The 3x squared over x squared plus 3x. So one more. The exactly infinity over infinity is right. We have infinity over infinity form. You have to ignore lower term by using relative ratio growth. You can cross out x squared. Answer is 3. We have 3 like step 2. This is not a final. Not a final. Step 3 is take what? E. So this is take E here. EQ. This is like a final answer for solving this problem. So one more. You can guess what is answer of this question. What do you think? Could you guess what is the answer? Could you write your answer on the chatting board? You can guess. Here, 1 plus 3 of x to the x is, answer is e cubed. What is 1 plus 5 over x to the 2x? Answer is 2 to the e to the 5. It's a good guess. It's a good guess. How about other students? You have the same answer or not? E to the 5? E to the 5? The answer is e to the 5 times 2. E to the 10. So we have one good shortcut. Limit x value approaches positive infinity, 1 plus a over x to the power bx. What is the answer? E to the power a times b. We have 원군 rule, like this. 원군 rule. So one more. The limit x value approaches infinity. 1 minus 3 over x to the power 2x. What is the answer? What do you think? What is the answer? So could you write your answer on the chatting board? E to the 6 is right. E to the 6. E to the 6. Here, what's it like sign of middle one? The sign of middle one is positive 1. Here we have negative 1. What's that? You can change it to the negative 3 is like A. The 2 is like B. We have e to the negative 3 times 2. Answer is e to the negative 6. So really be careful. We have positive 1, true. Negative 1, or take negative. Right? This is like exact answer by using shortcut. The shortcut. Okay. So this is all for today's lecture. So if you have any question, you can write your question on the chatting board. So if you don't have any more question, you can leave live session. So anyway, really appreciate that you attend my class today. I will give like section 7.8 today evening. So thank you for attending your class. So thank you. Oh, you're welcome. Okay, time waiting. Okay, you're welcome. You're right. I have one more session, the 7:30 p.m. today. I will cover section 7.8. 7.8 is improper integral. Yes, I will give the one more section today. You're right. Yes. So thank you for remind. Thank you.